Borg Elarab International Airport. Borg Elarab International Airport is located in Borg Elarab city by the Mediterranean Sea, about 40 kilometers away from downtown Alexandria. This project was executed by the Egyptian Airports Company and financed by Japan International Cooperation Agency. The existing passenger terminal Building 1 was designed to accommodate 1.2 million passengers per year and started operating in December 2010. Due to the increase of demand during the construction, this capacity was raised to 1.8 million passengers to cover the expected increase with the construction of an additional boarding bridge and training the airport staff. Regarding Phase 2, the development of the first eco-friendly airport in Africa. Based on the forecast of annual passenger demand, which estimates that the demand will increase from the current figure of 2.7 million to 6 million in 2030, Egyptian Airport Company decided to develop the new low-cost carrier terminal building to accommodate 4 million passengers, excluding the 2 million that the existing terminal building accommodates today. Currently, the world countermeasures for global warming are very important. Egyptian Airports Company decided to transform this airport into an eco-friendly one, as previously planned in the design stage carried out in 2011 to 2012 and 2017. This Phase 2 project has a 36,000 square meter low-cost carrier terminal building, apron for 16 stands for Boeing 727-200 aircraft, a parking capacity for 1,000 vehicles, and many green facilities are incorporated. Introduction of technology for environmental measures. System and/or equipment introducing in this project. Photovoltaic power supply system, VRV system in HVAC, building management system, BMS, LED lighting equipment, human sensor for switch on and off in the lighting of toilets, water supply using recycled water in irrigation network for planting from sewage, installation of fuel hydrant system, introduction of shading glass. Photovoltaic power supply system, volume of power to be generated 1,400 kVA, reduction of CO2 per year 1346 tons. VRV system in HVAC. The air conditioning system for the passenger terminal building uses a VRV, variable refrigerant volume system, which depends on electricity as an energy source. The airport is close to the Mediterranean Sea and is located in an area that requires air cooling in the summer and heating in the winter. In such an installation environment, we have adopted this method as a way to simultaneously achieve compatibility with facility functions and energy conservation. This VRV air conditioning system is expected to work extremely efficiently according to the load and is also expected to achieve a significant energy-saving effect of more than 30% compared to conventional on and off control. Irrigation network by recycling water. Airports require a large amount of domestic water and generate wastewater corresponding to the amount. At this airport, the generated sewage is collected and advanced treatment is performed at the wastewater treatment facility to reduce the environmental burden. Then this treated water is reused for the irrigation of green areas, thereby reducing the environmental burden and water waste. The outline of the plan for the wastewater treatment facility is as follows. Daily average wastewater treatment volume 1380 cubic meter per day. Irrigation tank capacity 1070 cubic meter. Daily water usage 300 cubic meter per hour. BMS. An important concept of the building management system is to achieve an efficient energy management environment. A centralized management system is used to monitor, manage, and control multiple systems from airport systems, HVAC, lighting, and security. The central management system acts as a single point of entry for users to operate, monitor, and optimize building automation. It is flexible enough to allow scalability to add and manage the airport complex system. Under this centralized management system, the BMS uses the design CC system in combination with Siemens control. The BMS can perform eco monitoring for power, lighting, HVAC, safety, and other third-party systems. Fuel hydrant system. Aircraft fuel is transferred from fuel tank facilities to aircraft through fuel hydrant pipeline and system. Using this fuel hydrant system instead of bigger fuel vehicles can reduce CO2 volume exhausted from the airport. Other systems and/or equipment aiming to be introduced in the airport. Electrical bus, vehicles, Follow Me, and other facilities, as well as GSE vehicles like forklift, towing tractor, and cargo truck inside the airport. Electrical shuttle bus for the passengers from the airport to the station will be established near the Alexandria region in the near future. Electrical GPU, Electrical Ground Power Unit. Emission control equipment for generator. Waste control and treatment equipment and/or system inside airport. Final words. The Egyptian government will continuously develop this airport as an eco-friendly one to minimize the impact of global warming.